Hello, everyone. My name is Trevor Cook. I'm going to talk about two of our offerings, one under NEUP and one under NEET. They're related. They're both on cybersecurity. This is a completely new area for us this year. Just a little bit about myself as a way of introduction. I've got over 30 years in this nuclear business. I've worked in private industry. I've worked for national laboratories. I've worked for utility companies. And for the last 25 years, I've worked for the Department of Energy in a variety of capacities. Presently, I'm the Chief of Staff to the Deputy Assistant Secretary for Science and Technology Innovation. I think if you read the papers or listen to the radio or watch TV, you've heard of cyber threats. Probably, if you work for government or related to government, you've already had your identification hacked or stolen. I know I have, and my wife has. My daughter has. So cyber threats are real. They're real for our industrial complex, and they're real for our nuclear industrial complex. Some of the most recent ones to hit the news are here. They're not necessarily the most recent ones that have occurred, but they've all recently hit the news within the last few months, just as a way of pointing out the importance and the real threat. People in China have hacked the Canadian National Research Council, which is their leading source of research and development for their country. They've hacked our own United States Government Office of Personnel Management, and they've obtained essentially all of the security clearance information for all of the cleared personnel in government. Russian folks, people in Russia, I don't know who they were working for, have made cyber attacks against U.S. energy companies, including stealing vast amounts of information and exerting some control over systems that are operated in the U.S. energy industrial complex. The Department of Energy was hacked. That's where they got my information and my wife's information. And luckily we did make an arrest in that case. And as it turns out, China has even hacked the control systems for the Israeli Iron Dome missile defense system. So their hackers can get into almost anything. There's a strong regulatory presence in the nuclear industry, and that's our U.S. Nuclear Regulatory Commission. And they recognized post 9/11 that cybersecurity was a real concern for the industry. And they started promulgating regulations which have culminated in this rather comprehensive regulation, 10 CFR 7354, protection of digital computer and communication systems and networks at nuclear power plants. These are at commercial nuclear power plants that make electricity. To help people meet the many requirements of that document, the NRC put out a reg guide, 571, which is essentially a prescription, a formula, that if you follow this, you can demonstrate that you have met the regulations that are in 10 CFR 7354. Further, the NRC has also issued another reg guide to talk about how computers can be kept safe from cyber threats that are used in safety systems for nuclear power plants. There's another important piece of the regulatory framework that I didn't put on this slide or on any other slide, and that is that there's a presidential directive that the federal government work with industry to protect our national infrastructure, our energy and other infrastructure assets against cyber threats. So that's important, and that's one of the reasons why the Department of Energy has a role, an important role, in helping industry with cyber threats. So how do you implement cybersecurity? Well, this little cartoon shows that the first thing you have to do is assemble a team of knowledgeable people. These are people that have to know how your plant works, how your plant's information systems work, know the regulations, and to some extent, the more the better, understand the threats against those systems. Then you go through a process where you look at both your permanently installed systems and systems that are portable, that move in and out of the plant, whether it's a personal device, an iPad, a computer, anything that might end up being a carrier or a threat into the system. You identify, once you've identified all of your systems and structures and components, then you identify what are critical assets. And critical assets affect the safety function of the plant, whether that's the actual literal safety per se of the plant, keeping the fuel in a non-melted configuration, or whether that's the perception of safety, whether it actuates the emergency operations center, or whether it makes a call to the governor to say that we've had an accident at our plant. You don't want those things to happen. And then finally, once you've identified everything, you've identified the threats against it, you implement a program to protect against the threats, to protect that specific equipment from the specific threats that can be levied against them. So what is this R&D program that we want to sort of kick off with the NEUP and NEET award? Well, what we're trying to do is obviously reduce the vulnerability of our nation's nuclear infrastructure. We also want to understand and mitigate the consequence of challenges to digital systems in that infrastructure. We also want to accomplish lowering the costs. Compliance with the regulations in cybersecurity is extremely manpower intensive. Over 5,000 pieces of equipment are identified for the typical nuclear power plant. Each one has to be tracked and vetted. We'd like to find a way to lower the costs for this activity. And we also want to provide a partner. Per the President's directive, that government partner with industry in this. The Department of Energy wants to be your partner, wants to be the industry's partner, the university's partner in dealing with cybersecurity. So these are just a few sample cybersecurity needs. There are many, many more possible. Just to run through what's on the slide, we're looking for technologies and methodologies that ensure that our sensors and networks and communication systems can work after they're challenged, and that if they don't work after they're challenged, that they fell in such a way that it doesn't stop flow of electricity. Electricity must flow. So we don't want any real safety challenges to the plant, and we don't want to interrupt the operation of the plant. The electricity needs to keep going. Modeling and simulation is another area for our R&D needs. What we'd like to be able to do is to take some of our existing codes and our emerging codes for understanding the behavior of nuclear systems and apply those to the kind of offsets, the kind of upsets that you get from cyber attacks. Because we want to understand if someone were to be able to come in and cycle a switch, cycle a valve, cycle a pump, change the, make some sort of little control system change in the plant, does that mean anything? Does it actually have any real safety implication for the plant? Would your normal systems catch that very quickly? Would you be able to isolate it, et cetera? So there's a big modeling and there's a area in modeling and simulation to better understand what the threats are and apply the existing codes and the emerging codes to understanding those threats and vulnerabilities. Another area is personal protection. Insider threat is one of the big threats for nuclear power plants because most of the systems that we have are not online. They're not accessible by external networks. So it's someone that brings in a threat, someone inadvertently or on purpose that brings in a threat, and then that threat is spread through the isolated network at the plant. So we'd like to conduct R&D for understanding that threat better and mitigating that threat better. Okay, so there's two offerings here. There's a NEET and a NE-UP offering. So in the NEET offering, we're looking for industry folks to do what it says here on the slide, develop a methodology to resolve consequences from cyber attacks. Again, it's important to understand exactly what the upset condition will be for the plant for credible cyber threats. Will the power still flow? Will you have to shut down, etc.? And once you have figured out that methodology, once you have that, to demonstrate it on some particular aspect of the plant systems. So that's what we're looking for in NEET. For NEUP, we want you university guys to be more self-reflective and look at research reactors, not power reactors, research reactors. And I probably should have said before, in NEET, that's open to anything. Power reactors, research reactors, fuel fabrication facilities. It's open to anything that's nuclear related. But for the NEUP, we're looking specifically at research reactors. And here what we'd like you to do, preferably, if you have a research reactor, would be to focus on your own plant. You don't have to. But sort of the idea was that it would benefit you if you did. To identify potential vulnerability, to understand what the consequence of that vulnerability might be were it to be attacked, and to conduct an experiment either through modeling and simulation or an actual physical experiment to see, if I caused the valve to open and shut 1,000 times, does that fail the valve? If I caused the pump motor to wind up and wind down, does that fail the pump? So we'd like you to conduct experiments, or you can do it by analyses. And then what we'd like you to do is take the lessons learned from this experience and fold it back into your curriculum to make future generations of scientists and engineers more aware of cybersecurity and its potential threats for nuclear power plants. And one point that's important to make is that these awards, neither the NEET nor the NEUP award, are really focused on your own personal compliance with regulations. So that's not what these are for. These are R&D, and we'd like to keep them in the R&D realm, but they should, of course, benefit yourselves in industry and universities. So I think that's about it. For further contact, the person in charge of this program at the Idaho National Laboratory is Stephen Ehrenstein, and please feel free to contact him. You can also contact me, Trevor Cook, at the address that you see on your screen. And Stephen is, I believe, he's listening and is available to answer questions.
We will take any questions now, if there are any directed at Trevor. The first question is, does this focus only on reactor core or on the entire fuel cycle?
The entire fuel cycle, for both research reactors and for power reactors.
Could you expand on resolve consequences as it is critical to understanding the scope?
I think so. Let me go back to that slide. Okay, there it is. Okay, so what we're looking at is anyone can come up with a threat, right? Anyone can say, oh, I think someone can hack the controller for the fire suppression system and cause actuation of the fire suppression system, something like that. So what? What does that mean? What does that mean to plant safety? What does that mean to plant availability? That's what we're talking about when we say resolve consequences. So if there is a threat vector and someone is able to execute on that, what does that mean to the condition of the plant, to the operability of the plant, to the economics of the plant? So that's what we're talking about when we say resolve consequences.
Is there any interest in algorithm development, such as encryption algorithms?
I don't think so, but I may be wrong on that. So, Stephen, if you're available to chime in on that.
It doesn't look like he's on the call.
Okay,
right
so
now,
I suppose it would depend on the context. If you're talking about encryption algorithms for control signals to and from components, possibly yes. If you're talking about just sort of generalized encryption algorithms to protect people's information in a database, probably no. But I'm actually not the expert in this, Stephen.
If a project is proposed for a specific facility, would results of the study be public domain information?
Well, what's the answer in general for this? So yes. Now, if it borders on the security of your facility, then probably we can get around that. We wouldn't want to publish anything that would adversely affect the security of your facility.
So which program addresses risk-based methods?
Well, we have a number of programs that address risk-based methods not in the cybersecurity realm. So those tend to be things like the Light Water Reactor Sustainability Program, probably is the most the best example of that. But to some extent, all of our reactor and fuel cycle programs are risk aware and have components that look at risk and risk methodologies.